This Whelen aircraft power supply was sent out as broken in 1980 and returned by Whelen, stating there's nothing wrong with it, it just requires a synchronizer unit. And due to the fact that I have that synchronizer unit, I decided to hook this system up and see how it worked. And it did work. You can't tell in the video, but the output to the strobe is a little anemic from what I could tell. It seemed like it really wasn't quite the brightness that I had expected. So I started doing some metering, and the voltage was a little bit below what I would expect at the tube. The highest I was getting was like 250 peak, which is a little bit low. It's not so low that it won't fire, but it is a little lower than I would expect. This particular model of aircraft strobe requires a synchronizer, and the specific power supply would be one power supply per strobe head. So the synchronizer would synchronize them all together. So what's going on? Well, have a look here. You can start to see there's a little bit of buildup on the main cap, and that's steam venting from this secondary charging capacitor. And it wasn't apparent immediately, but I started to smell some electronic-y sort of goodness. And so I zoomed in and I started to try to narrow down where it was coming from. And at first it was really hard to tell. But as we'll see here in a second, it's not so hard to tell now. It's actually bubbling off there from the relief portion of that capacitor, and now we've got the, as I put it, magic smoke has been let out. And this is what it looks like after I removed it. It is still bubbling off through the relief portion of the capacitor. So it was definitely just a failed component, which would need to be replaced. And I did inspect it here and came to the same revelation.
Ooh, magic smoke. Right there.
And since magic smoke is never a good thing, it became time to tear this power supply down, remove that damaged capacitor, and replace it. There was also a ceramic disc capacitor next to it that was damaged just based on the fact that it was glued to that capacitor. I'm not sure if I damaged it taking it apart or if it was just damaged in general from the heat cycle of that failed capacitor, which was in fact very hot. So I have plenty of these ceramic disc capacitors, so I went ahead and installed a new one of those, since that would be an easy thing for me to do. That way be ready to go when I was able to dig up the correct larger capacitor. That larger capacitor is a 5 microfarad 500 volt capacitor, and not a lot of other supplies actually use that specific spec. This one is a little bit different in that respect, that it uses that specific size and type, and it's also the pin style on that one is not real common. So to get this thing working, just to test that there was nothing else wrong, I was able to get a 450 volt 5 microfarad capacitor with a different pin style, and just solder some wires to it, and just for testing purposes, just real quickly solder those to the positive and negative on the board, just to test that I had in fact addressed the problem before I ordered a replacement and before I went to the trouble of going further. And if there was a different problem, this would help me troubleshoot it. What I was able to figure out with this less than stellar setup was that it appears the failed capacitor was at least the lion's share of the problem, and ordering a new one would be worth it to get the power supply back to working order. And they're only like $6. They're a discontinued capacitor. They're a lot larger than the modern ones would be. There haven't been huge advances in electrolytic capacitors, but they certainly aren't nearly the size they used to be. And in this case, as you can see, this one is significantly smaller with very similar specifications. So with it working like this, it's time for me to head onto the electronics website and buy myself a, and that was hot because it should be attached to metal, and it wasn't. That was my mistake. Very hot. So I went ahead and resecured that component to metal so that it would not get so hot. And then I went ahead and unsoldered or desoldered the makeshift capacitor from the bottom of the board. And I figured I would attach it to the top of the board, at least temporarily, so that testing wouldn't be so awkward. That way I could at least close it up and test it more thoroughly without everything opened up. So I just ran those little wires that I had used as jumpers just through the board and connected them the way they should be connected if the correct capacitor was there. That not a big deal. This will be easy to take off when I get the correct component. And it also makes me go to a lot less trouble in going through and testing this power supply to make sure there's nothing else I need to order. So hooked it back up, connected it back to the synchronizer. The flash rate control is actually on the synchronizer module. And so I did run it up and down in flash rate just to see if we'd have any misfires, failures, or problems. I did not find any. It seemed to be much brighter, and the wind-up sounded a lot more normal to me. It doesn't show well in the video, but I considered this power supply to be back to normal working order. Really, the only thing left to do was to stick the meter on there and see if the voltage at the tube was any more reasonable. I'm wanting to see over 300 volts at the tube, not randomly an anomaly of 300 volts. So I'm going to want to see something a little bit. Yeah, see there, I'm getting 330, 340 volts, high 200s, 350s almost. So that's much more normal for a strobe. So I considered this to be repaired. And if not repaired, at least the problem has been addressed, and when the new component arrives, it will be installed. Thanks for watching my troubleshooting and repair of this power supply. Have a great day.